So in this video, we're going to talk about simplifying ratios, or sometimes this is referred to as the quotient rule. So simplifying ratios, also known as, aka, the quotient rule. Okay, so a ratio is just a quotient. So it's just one thing over another. So for instance, if I had say x to the 12th over x to the 3rd. So what this is saying is that I have 12 x's on the top, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? And these are all being multiplied times each other. And I have 3 x's on the bottom. So 1, 2, 3. So what we can think about is 1 x on the bottom cancels out with 1 x on the top. Because x over x is the exact same thing. It's like 5 over 5 is 1, or 3 over 3 is 1, or 17 divided by 17 is 1. So this second x would cancel out here with this second x. And this third x here would cancel out with this third x. And so what I would be left with is all the x's on the top. So if I count how many I have 1, 2, 3, 4, 5, 6, 7, 8, 9 x's left on the top. And I don't have anything left on the bottom, but remember when I cancel, I'm saying x goes into x one time, x goes into x one time. X goes into x one time, x goes into x one time. X goes into x one time, x goes into x one time. So what I really have on the bottom is 1 times 1 times 1, which is just 1. And then x to the 9th divided by 1 is still just x to the 9th. So you can think of the quotient rule. So if you look at what happened there, right, I think of the quotient rule, you can think of it as, if you look at 12 and 3, if I took 12 minus 3, I would have gotten 9. So the quotient rule says that if you have x to the a, whoops, that looks a lot like a 9, x to the a divided by x to the b, that is the same as x to the a minus b. Now, personally, I think that you don't really need to memorize the quotient rule, because the way that I think about it is I kind of look at this original problem and I say, okay, where do I have more x's? I have more x's in the top. How many more x's do I have? Oh, I have 9 more x's in the top than I do on the bottom. So I would have x to the 9th. And you can do that as you go through with each variable. So for instance, suppose I had, say, x to the 3rd, y to the 15th, z to the 4th, divided by, say, x to the 7th, y to the 4th, z to the 10th. So we're going to go through letter by letter. So the first letter is x. So if I look, I have 3 x's on the top, 7 x's on the bottom. So the first thing I ask myself is, where do I have more x's? Hopefully you guys are thinking in the bottom. I have 7 of them, right? 7 is more than 3. So I have more x's in the bottom. How many more x's do I have in the bottom? Oh, I have 4 more x's. So on the bottom, I'm going to have an x to the 4th. If I look at the y terms, where do I have more y's? I have 15 of them here in the top and 4 in the bottom. So which one is more? 15. So I have more y's in the top. How many more do I have in the bottom? Well, there's only 4 in the bottom and there's 15 here, which means there's 11 more y's in the top. So on the top here would be y to the 11th. If I look at this last piece, so I have 4 z's on top and 10 z's on bottom. So where do I have more z's? The bottom. How many more do I have? I have 6 more. So I have 6 more z's on the bottom there. So that would be my final answer there. Would be y to the 11th over x to the 4th divided by z to the 6th. And you can do the same thing even with more stuff. So what about something like this? I have 6wxy on the top divided by 24y on the bottom. Okay, so 6 divided by, so if I look at this now, I can look at the numbers. So I have a 6 on the top and a 24 on the bottom. So 6 goes into 6 1 time. 6 goes into 24 4 times. And then I also could cancel. I have a 1y on the bottom and 1y on the top. So left on the top, I have 1 times w times x. Divided on the bottom, I have a 4. Now, I don't need that 1. I can just write it as wx divided by 4. And that would be my final answer. All right, let's try one more here. What was I on? C. Okay. No, you know what? I could put it on this page. So let's try D here. So 25 v to the 5th w to the 5th divided by, say, 50 v to the 8th w to the 7th. Okay, so 50 and 25. 25 goes into 25 1 time. 25 goes into 50 2 times. If I look at, so I know I'm going to have a 2 on the bottom here. If I look at the v's, right, I have 5 v's on the top and 8 v's on the bottom. So where do I have more v's? Oh, I have more v's on the bottom. How many more? 3 more. I can do the same thing to look at the w to the 5th and the w to the 7th. So w's, where do I have more w's? On the bottom. How many more do I have? I have 2 more, so w squared. Now, you can never have a fraction that looks the way it's written currently, because right now I have nothing on the top of the fraction. Every single fraction has to have something on top. And you might say, well, but Dr. Gorman, we got rid of everything on the top. So if you end up getting rid of everything on your top is always going to be a 1. Because really what we're doing is we're canceling things out, right? Really what I'm saying is v to the 5th goes into itself 1 time, and I'm left with 3 extra v's here. W to the 5th goes into itself 1 time, and I'm left with 2 extra w's there. So that's kind of how you want to think about the quotient rule.